Welcome to the Machine Learning at Home. Today I will speak about new method of machine learning, which is support vector machines. Support vector machines try to do very complicated work in order to separate our classes in hyperspace. So hyperspace is not from science fiction. In our case, it's just a thing made of all variables we want. So for example, our iris data set is a hyperspace of 4 dimensions because we use 4 characters. So in that hyperspace, SVM will place multiple support vectors, sets of numbers, simply say. And these sets of numbers will try to separate 3 different species of irises with kind of hyperplane. So this is a hyperplane and hyperspace method. It sounds complicated, but it's actually very simple. So let us go and load the library. Fortunately, this library should be already installed if you use naive Bayes method. If you didn't, you should tell R to install it, like install.packages e1071. If you already installed the library, you should simply call it by library e1071. Then we'll provide train and test subsets. So we can make it from iris data and use it rows part for selection. And this is a logical expression which I typically use, the shortest one, and then we reverse it to make a test subset. Then we'll run SVM function. I will immediately create model object iris.svm function called svm lowercase, has formula interface, so species against everything else, and data is equal to iris.train. Alright, so now we can, like, out of curiosity, type iris svm. It will tell us something about the model. So for example, you can see that there are 20 support vectors which separate our 3 species in a hyperspace. Now we can use that model iris svm to make a prediction. So iris svm pred will be result of prediction function predict from iris.svm, and we need new data, which is iris.test, but without last species variable. Yes, I made a mistake, said without, but for some reason didn't specify minus. So now should work. Okay, works. Now what is left is to make a table out of initial species iris test variable number 5 and predicted species, which is iris svm pred. Not bad, I would say. Not very well, worse than, for example, linear discriminant analysis. Especially bad is versicolor, in which like almost 1/3 of observations predicted as Virginica. Virginica is better, only 1 is predicted improperly, and Setosa, as usual, is simply perfect. So now, like, to some sideway things about machine learning. Many methods of machine learning allow you to understand the feature or variable importance. Unfortunately, SVM is a black box, so it does not have this method embedded. So we can still access it and make some more or less complicated calculations to understand which character is more important, but by default SVM does not allow it. However, it allows to calculate probabilities of class belongings. So for that reason we should repeat our SVM from the beginning with slightly different parameters. So let us repeat our first one and say probability equal to true, and I would change the name into SVM2, and then we make a prediction step with same probability equal to true, and also use our second model and also rename result. And finally we access these probabilities of class belongings with a way similar to KNN. So probability stored in the attribute of the object aris.svmpred2. So we should use function attr to access attributes. Attributes of aris.svm pred2, and name of attribute is probabilities. Probabilities in quotes. And we typically wanted like rows from 60 to 70, so should be good here as well. Okay, sounds like we made it. Yes, so as you see, we can have some probabilities of class belongings. Typically versicolor and virginica are not very well separated, so yes, you can see that some rows, for example row number 77 has like 24% of probability to be versicolor and 71% probability to be virginica. Even worse example is row number 86, like 39 versus 50% of probabilities. Okay, that's what SVM complicated but powerful method can be used for. So it is not so universal as CART and naive Bayes method, so it will require numerical data, but it's very powerful and can operate with a very big amount of data. So SVM is popular and frequently used. It's a black box method, so sometimes it's not easy to explain what exactly happens, but in many ways we don't need to have it immediately at least, and we'll use SVM. So that was support vector machines. Thank you very much, and we'll continue next lesson.